Hey, everybody, and welcome to this fourth episode of the Filtra.io podcast. For this episode, I talked with Jean-Baptiste Kempf, the CTO of Scaleway. Jean-Baptiste is a prolific engineer and entrepreneur who is also deeply invested in the Rust ecosystem. In this episode, we discussed Scaleway's mission to become a true European hyperscaler to rival the American and Chinese giants. I couldn't resist also asking about their AI buildout, including how that intersects with their clean energy goals, and how hard it is to get GPUs. And of course, we also talked about how Scaleway uses Rust for some of their most critical infrastructure. It was an unexpected and super fun opportunity to talk to the CTO of a major public cloud. Before we dive into this interview, a couple of reminders. Be sure to follow Filtra.io on all major platforms. And if you're looking for Rust jobs at cool companies like Scaleway, check out our extensive job board over at Filtra.io. So, Scaleway is a European cloud provider and a subsidiary of the Iliad Group. Um, can you tell me about the Iliad Group? Because I think there might be some people in our audience who are not familiar with it.
I would be surprised if any or many people actually know about Iliad. So Iliad is a telco group, right? It's at the origin, it's a phone company and a DSL company who now does fiber, right? A classic ISP who is a bit like not the usual one, right? So it would be closer to T-Mobile, right, in the US, right? Doing things a bit differently, cheaper. And it grew and grew and grew. It started in late, I think, 90s. And it became one of the larger ISP in France, first on landline, then fibers, then mobile. And then it grew also in Italy, in Poland, in the Netherlands. So it's now around $12 billion business.
So, um, obviously, you kind of just explained Iliad is huge in Europe, and Scaleway specifically is really focused on providing a European cloud alternative to some of the hyperscalers that we have in the world. And that's a really important selling point for your platform, right?
Yeah. So if you look like on the global scenes, right, there is like three hyperscaler from the US, maybe four if you count Oracle, and then maybe two from China, right? And the rest, well, doesn't exist. And the problem is that in order to arrive to a good scale, you need to be like at a large level, right? Because then you can buy a lot of hardware, and so the cost of hardware goes down. There is a lot of software to be developed that is cost a lot of money. But so like there is a big cost at the beginning, right? But when you arrive to at least $1 billion of revenue per year, then you can start scaling and competing. And so far in Europe, there is no company that is a true hyperscaler. And the idea with Scaleway is to try to arrive at that point. So it's not there yet, but it like has a quite large growth, around 30% year per year. And like with what happens since like 2 or 3 years, there is a lot of distrust in the world, right? Between China and the US, between the US and everyone else, to be honest. And so like having access to being sure that you can still have a solution if everything goes wrong from the hyperscaler from the US or China is important. And so that's why there is a lot of question about European tech sovereignty, and that's one of the main selling point of Scaleway. And Scaleway, compared to other European alternative, is a true cloud provider, right? Like it used to own data centers. It doesn't anymore. It has been spin off to a different company. It's really like we rent rooms inside data centers, and we are a software company, right? So it's really like focused on software. Everything is cloud native, right? You consume everything through APIs and Terraform. Like it's not it used to be a hosting provider, right? Now it has moved to an actual cloud provider. We have around 100 products. That wasn't the case 5 years ago, right? We developed a lot, but now you have everything you expect from a cloud provider. Everything is consumed the same way with the same type of API, same building, and so on, right? So it really looks like AWS or GCP, except it's smaller.
Yeah, that's very cool. I didn't know that there was specifically a billion dollar threshold where if you could pass that, you
Well,
could
for
start.
example, like the problem is like when you're a cloud provider, you have a lot of capex costs, right? You're buying a ton of machines, right? And when you start buying machine by, I don't know, like the thousands, right? Then well, the cost goes down quite a bit, right? So there is that. And the second thing is like there are so many products you need to do, right? So there is around 880 to 100 products you need to be a true cloud provider, right? And once it's done, right, you can scale to so many people, right? But there is like an amount of time that is the minimum that you need to invest, right? And if you're a small company, like those engineering time cost a lot. While if you're larger, it's less, right? My approximation is that the amount of money you need to just do the software for a basic cloud provider, a correct cloud provider, is the order of magnitude of investment of $1 billion just for software. And this is just developing the software, right? It's about doing the Terraform, the Ansible, scaling everything, doing multi-data center, failovers, having everything on the API integration, and so on, right? And this is before maintaining, right? Of course, you do that over, I don't know, 5 years, right? But that's still $200 million investment per year, right? So if you're a $300 million company, that makes no sense. If you're a billion one, that's right. And this is why, and this is why you arrive with hyperscaler who are like a lot, not that many, right? And when you're a large cloud provider, right, you can even develop your own hardware. And if you develop your own hardware, then you have like some good things that you cannot do when you're smaller.
Yeah. So it's a scale economies business, I guess.
Yes, but it's a very technical one, right? Like you need to be highly skilled, right? So that also makes it more difficult.
Right. Um, and actually, I was thinking about asking you this question, then decided not to, but now I'm going to ask it again. Um, because you mentioned it, there's so many products that are in that the big public clouds provide. How are you deciding like what to build, or do you feel like you have everything built already?
No, we cannot like compete at all, right? But you can see that there are some products which are like the base ones, right? And then you have things which are just like something for a niche, right? So, for example, um, you have several layers, right? Everything that is close to the bare metal, infrastructure as a service, um, those are common blocks, right? But for example, and this goes from like really bare metal to serverless function or inference as a service, right? Those can be for any type of verticals. The cloud providers, the hyperscalers go even further, right? They have like business solution for this type of industry. They have a specific like for each of the industries, which is why they have so many products. But if you look, like there is a common around, you can count between 60 and 100, 120, which are the common base that everyone is using. And so our vision is, in order to compete completely for everything that is basically vertical specific, business specific, we're going to have a marketplace with third parties who are going to do that.
That makes sense. So the other thing I was wondering about products is, you know, because you're focused on serving Europe, um, I feel like one thing that you might try to do would be to make products that somehow focus on the European market. Are there special things you do to comply with GDPR or other things that serve Europe better?
Yes. For example, the way we develop Scaleway is in a very privacy-focused way, right? So everything is encrypted, whether it's on disk, on block storage, object storage, on file storage, everything that is the VPC, the networking, everything is encrypted in a way that for us, it would be difficult to access the data, right? So we're doing it in a way that even for us as like runner of the cloud provider, accessing the data would be like a nightmare. And this is ingrained at the beginning from day one.
So, um, I guess if you're a cloud provider today, especially if you're a cloud provider that's trying to grow a lot, that means you are an AI infrastructure company kind of by default, right?
Yes. Yeah. So like the story of Scaleway is a bit complex, but at the beginning it was really like a hosting for like websites in the 90s, right? Like early 2000, right? And then it was like dedicated servers for a long time. And around 8 years ago, it started to do some cloud. And in the last 3 years, accelerated a lot. But in the last 3 years, at the same time, we started like deploying large amount of GPUs, right? We probably have deployed so far 6 to 7,000 large GPUs, right? And including ones which are like basically training clusters to do inference, to do training of models, like 1,000, 2,000 H100 equivalent, right? So those type of machines that are used for very large AI companies. So yeah, so those are the things that we've been doing, but this is just part of the business. The rest is like the rest of the cloud, because if you look clearly, what you see is that especially on inference, you need to access to a ton of data in order to run the machine learning, right? And the models. And therefore you need to have a good like object storage and a good data storage, right? And a big like a data warehouse and so on, right? Because you're going to work with data, right? And so this brings so much of the cloud stack that you need that anyway.
Yeah. Um, is it uh I've never had the opportunity to ask someone who runs a cloud questions about this. Is it hard to get GPUs?
Yes and no. It depends. It depends on which one you want and at which time, right? And so you need to, if you're clever, you can allocate them and ask them in advance. And well, it is a very volatile market, to be honest.
Yeah. So what specific cloud services are you building for AI?
In the end, what most of the people are consuming is something called inference as a service, right? So you basically we run the models on our GPUs in the best way possible, and you just pay by the token outputted by the model, and you price per complexity of the model, basically. And so this is the most used AI product. Then, of course, we have like dedicated GPUs, virtual machines, cube pods, bare metals GPUs. We have a lot of those. And then linked to that, you have everything related to data pipelines, MLOps, data ops, Jupyter notebooks, and so on.
Okay. So it sounds like you have a pretty complete set of offerings.
Well, I'm not sure it's complete, right? But at least it's not ridiculous, right? We are at a point where, yeah, we have a good alternative, right? It's not as good as, for example, Google Web Vertex or stuff like that, but at least you're not in the case where we are just like at the beginning.
Right. It's competitive. Um, so something that kind of made me really raise my eyebrows when I was looking at into Scaleway is your commitment to only using renewable energy for your data centers. It seems like that would be very hard right now with AI and the massive energy demands of AI. What does that look like for you?
Well, the thing is, like most of our data centers are in France, right? And France is around 65 to 80% nuclear energy, right? So if you look at the energy mix of France, we're around per year 30, 40 grams of CO2, right, per kilowatt, right? And when you compare to Germany is around 10 times that, right? 300. And people like Poland are at 700, right? So if you go to electricity maps, right, you will see that, right? But it's not, I'm not sure it's really renewable. Um, but it is low carbon electricity, right? And so we are deploying data centers in Sweden for the same reason. Although that, of course, when you compare to the US, right, the US is absolutely catastrophic on its energy mix, right? It's also, I don't know, probably 300 also, right? So, yeah. So we care about that. And the second thing we do, which is quite also interesting, is the fact that we use two of our main data centers are called adiabatic data centers, and so they don't really use AC to cool things down. And this is good because it decreases the temperature, the percentage of overhead, right? So we consume less electricity, and the electricity we consume is mostly nuclear.
Yeah, that's really interesting. I wondered if that maybe was the case because I knew that France was very heavily nuclear. So being in France is kind of an advantage for you in terms of achieving that goal.
Yes, I think so. But like, if you look at the worldwide electricity mixes, what you will see that, for example, Quebec is quite good. Sweden is quite good because of hydro. You can see that, so part of Canada, and France, right, is pretty good. Um, Spain is okay, and Portugal are okay. And I think some part in south of US are also okay because of a large amount uh, of
Solar.
solar. Yes.
Yeah, that's very interesting. So, um, one of the things I came across when I was looking up information about your AI work is your partnership with Qtie. Am I saying that right? Is it
Yeah.
Qtie?
Yes.
So can you tell me what Scaleway is doing to support Qtie?
Yeah. So Qtie is not really like it's a bit. It's an AI company, but a bit different from OpenAI or Mistral or Anthropic, right? It's mostly a research lab doing some new AI model. It's a bit like what OpenAI should have been at the beginning, right? A non-profit. For example, it did something quite interesting, which was called Moshi, which was an LLM which was pure audio, right? So it trained on audio data, and instead of doing what everyone else is doing for audio assistant, which was audio to text and then text to text with LLM and then text to speech, right? Using mostly 11 labs. It's doing it directly, it's trained directly on audio data, right? So it's audio to audio as an LLM. It's quite rare to see that. And Qtie is mostly training on our large clusters.
Cool. I didn't realize that Qtie, or rather that Mochi was specifically audio to audio only.
Yeah, that's one of the main case of Mushi, right? It's of course it's not like it's not the best LLM, right? Because it was not trained on enough data, right? But it's a speech text foundation model, right? Which means that it's extremely fast. Um,
Yeah, and I mean you wouldn't have those translation steps, right? Like the other models.
yeah, because those ones are like a bit like too slow, right? And there is another one that they did, which is called Hibiki, I think, and it's basically doing exactly the same, but for translation, right? So audio to audio translation.
Okay. Very cool. Super cool. There's actually, I mean, you and I were talking about this um, before we started recording. It feels like Paris has become a really important tech hub.
Yeah, I would say that like outside of the US and China, you have Israel and then you have Paris, right? Which are the major startup hubs lately. And Paris has a lot of AI startups. So that's pretty cool. And that's a bit of change because in the past, maybe the core of AI, well, startups in Europe would have been Berlin or maybe London. And this has changed a bit, I think.
Yeah. Is there any reason why you think that has been the case?
Um, yeah, around 10 to 15 years ago, a few people, including Xavier Niel, the founder of the Iliad Group, decided that, well, we should do something, right? And so, again, for example, we have something called Station F, which is one of the largest, if not the largest, startup incubator in the world, where there is like places for 6,000 people. And there was like a huge push from the government to say, well, we need to showcase what we can do, right? Because the French have like lots of very good engineers. So let's build something. And of course, it's a lot of marketing around the French tech and so on, but it brought a lot more people to that, and a lot of like students now they want to actually work in startups and not for like large groups and so on. So there is a mindset change that has happened in the last, yeah, 15 years, right? Since 2010, and this is important.
Yeah. Even within the Rust community, I've seen such a density of companies in the Rust community that are in Paris.
Yeah, I think that like the French education system focuses a lot on math. So there is a lot of engineering who are good at math. So you see a lot of people around compilers and language and so on, right? And you've seen that before, right? Like you had things like, for example, a lot of things on something called Coq. I don't know if you remember that one, which was like a formal C. There have been a lot of things on functional languages, Camel, OCaml, for example. There is a large community around languages and a bit on compilers for a long time, and I think that this is um, quite the reasons why you see that also in Rust.
Yeah. So I mentioned, Rust, and that's kind of why we're talking. So tell me, how does Rust fit in your tech stack? What do you use it for?
I personally use Rust in many parts, right? Because I have other jobs, right? And we could talk about all those type of use cases of Rust. At Scaleway, it's used for almost all the networking products, right? So everything like um, virtual VLANs and what we call VPCs and managed VPNs and so on, right? So everything that is basically around the low-level network management as SDN, right, is in Rust. Um, at the beginning, Scaleway was mostly a Python shop, um, and then moved. There is still a bit of Python, but mostly not anymore. And then moved a bit to Go, and most of it moved to Go. And then there is for projects which are lower level, who need a lot of who are closer to real time, right? So whether it's low level storage or low level networking, move basically to Rust.
Okay. That seems like a bit of a pattern that I've noticed with cloud companies using Go kind of as the default, and then Rust when you need the extra performance.
Well, the problem with Go in general, right, is that, well, it has a garbage collector, right? And that's a big problem, right? It's not a problem when you're doing like a SaaS API for whatever SaaS company you're doing, right? Because, well, you're going to serve, um, it's maybe going to slow down one client, right? So it's a bit less important, right? And you're going to spawn another session in Go and to answer the APIs, or you're going to manage pools and so on. So the garbage collector is not too much of a problem. As soon as you're in performance and real time, it's horrible, right? Because if you're the one person that is at that point on getting garbage collected, then, well, the performance is horrible, right? And this is like a huge problem, right? Everything that is, in my opinion, right, real-time networking, parsing, multimedia, right, Rust is a good fit and the best fit so far.
Yeah. I think it's a very natural fit for cloud, right? Um, I mean, and probably because of speed and reliability. Are there any other reasons why you feel like it's a really good fit for cloud that are kind of outside of the normal ones?
Um, yeah, there is like people. I think people underestimate the power of ecosystems, right? Why is so many things on AI done in Python? Well, because there is PyTorch and so many things around scikit-learn and so on, right? And why today there is a lot of, for example, networking? Well, because now a lot of networking, and mostly at the beginning pushed by Mozilla, but a lot of networking is done in Rust, right? So you have a ton of a huge ecosystem, right? You're going to do quick, well, everything is in Rust, right? And so on and so on, right? So I think this is one of the reason. I think C++ is a nightmare, became a nightmare. Um, and so like this is like also pushing so many people out. Um, I like simple languages. Um, and I like the fact that there is one correct way of doing things, right? And like in C++, you can do everything in so many times, right? You're going to do it templating, you're going to do almost function programming or some macro recursives or some compile time. It's just like, what, right? It's complex, right? And here in Rust, like there is a one correct way of doing that. There is also the fact that there is a good of everything related to Tokyo, right? A lot of async that is correctly done. That helps a lot in programming and make async programming something closer to the modern people who are using that in Node and so on. So that's also one of the main reasons I've seen for using Rust.
Yeah, I I think you're right about ecosystems. And I've had a couple of other people mention that to me. Do you do you feel like there are things that are missing in the ecosystem right now that Scaleway would like to have there?
Um, to be honest, I don't think so for Scaleway. Rust is a good fit, so I don't think there is much missing for Scaleway.
Yeah, I guess, I mean, we're talking about how good a fit Rust is for cloud and that sort of thing and networking. And so I think people have built up those aspects of the ecosystem pretty well. Um, so you, well, this next question might be a bit of a long shot. So if you don't have an answer, that's fine. But I was realizing that you probably see a lot of data about developer preferences on your platform. Is there anything you've seen that speaks to the Rust adoption picture?
You mean from clients or internally?
Yeah. Have you seen maybe like growing demand for things that support Rust?
Yes, but not that much, to be honest, right? I still think that this is like a language for, um, let's call it high-end companies, right? Very technical startups, right? So cloud provider, people doing multimedia, some people doing some AI, uh, things like parsing a lot of data and so on. But the global startups, well, we've seen like, and I've been in SAP Global for a long time, right? But like you had like the big Ruby and Railway things, right? And then it moved away to lots of Go and Go and Go, and then moved away to Node and Node and Node and Node. Uh, and so far, I don't see much change in the last Node Next.js change, right? There's a bit of less of React, but Next.js being so big now um, is kind of big. Um, so I see mostly, especially on robotics, embedded systems, uh, cloud providers, multimedia, video games, some Rust, because in those cases, real time is important. But this is mostly what I see. I don't see much more in the, let's call it the normal startups. Well, the majority of startups. I don't know if that's.
Yeah, no, that makes a ton of sense. Those are the industries that I see growing for Rust as well. And I think for a long time there were a lot of people that were very invested in the Rust for the web story, like literally building web apps in Rust and stuff. Do you think that will materialize, or do you think that's doesn't really
Mm,
make sense?
I don't think it will materialize. I think it will exist, right? And Actix is a very good framework, and I use Actix a lot on some of my other project. But the fact is, like, you grow with your community, right? And the community focus on something that creates an ecosystem that is focused on something, right? And you cannot be good at everything, right? And it's very difficult to explain to people, right? Um, it's the theory of comparison advantage, right? So you cannot be good at everything, right? So you're going to focus on a place where it's good, right? And you're better than others, right? And this is a niche which can be a very big niche, right? But like you're going to stay in your niche, right? And if you look at closely really at the web, right? The web has native um, JavaScript support, right? So it's obvious that there is like a natural interaction um, between like Node and JavaScript inside the web browser. You can say, yeah, but you could do things. Yeah, I know, right? And for example, I'm doing a lot of Rust. Personally to target WebAssembly, right? Because that's exactly what I don't want to do is to write any JavaScript, right? Because at the origin a C guy and an assembly guy, right? So um, now I do Rust and Zig and assembly, right? And I don't want to do too much JavaScript, but de facto there will be some niche, some specific cases where of course, you're going to see Rust, but I don't think it's going to be mainstream.
Yeah, I agree. Um, so one of the things I like to do with these interviews is try to give, because obviously we're a hiring platform and we like to give people the opportunity to maybe see behind the curtain a little bit what it's like working at the companies that we interview. And so a question I wanted to ask is, can you tell me about an interesting engineering problem that the team at Scaleway, you know, solved or took on recently?
It's difficult to find one because there is so many. But one of the invisible thing that people don't see at a cloud provider is the fact that every region is usually composed of three availability zones, right? So you have like three data centers, which are at least by 5 or 10 kilometers from the other ones, right? But the people are going to use it as one, right? And they want to hide the complexity, right? And so, for example, you have like a consistent same VLAN, same networking, like all of them are in the same place, right? And you want to adapt that for all of the users, right? And all the products. Of course, it's not possible, right? So you need to do um, uh, a lot of, I don't know, tech algorithms, converging algorithms to do that, right? And the two main places where you see that at Scaleway is everything related to the VPC, right, which is mostly done in Rust and using um, some software called RR. And all the management of IPs, right? It is a complex problem. It doesn't, it's a thing that, well, you've done networking along. It seems like easy, right? It's not. This one and the other one is object storage, right? Because large object storage, like, for example, at Scaleway in the Paris region, we host around, it's not that big, right? It's 150 petabytes, right? And the data is on several data centers, right? Because you can need to be able to lose one. And the converging, the algorithms to converge those are something that are absolutely invisible, right? And this is like really, really important and really cool. And this is thing that needs to be done real time. So we used to do that in C, and now we do mostly in Rust.
Cool. So I also saw that Scaleway is one of those companies that has a nickname for its employees. You call them scalers.
Yeah, it's also a bit of a joke, right? Because the idea is to be a hyperscaler, right? And scaling the company, right? So scalers is a fun one.
Yeah. Um, what makes a scaler, one of your employees, different from an average software engineer?
Um, I, like I created, I think, 10 companies, and I advise around probably 30 startups since now 20 years that I've been doing that. And I'm active in so many open source projects that you will see that I'm quite active. What you see at Scaleway is people are very competent, right? You're talking to do a cloud provider. It's a bit like the stuff I'm doing with VLC or FFmpeg, right? It is the people who are extremely good, right? A lot of those could work at any Google, Apple, Mozilla, Meta without any problem, right? So like the level, the technical level in Scaleway is very high.
Yeah, that makes sense. And it's kind of good to hear. I think you want your cloud provider to have a ton of in-house competence. So when I was reading your job descriptions, it sounds like Scaleway puts a huge emphasis on providing a really high quality of life and a really balanced life for its employees. Can you tell me more about that?
I think it's going to be difficult for American to hear that, right? But like we have like 5 to 7 weeks of vacations, and those are actual vacations, right? And if you like, people have like normal hours, right? They're dance hours, right? But they're not until 2 o'clock in the morning or 10 p.m., right? At 7 p.m., most of the people are gone, right? There is a lot of thing happening on sites, lots of events, large focus on training, right? Compared to a lot of like startups, especially startups in the US, like where you're working a lot and a lot more. This is pretty cool. Also because like we try to focus on being very effective, right? And that's very important because people forget about that. But being effective is important because that means that you can not spend too much time on meetings and other things which are basically destroying your performance, right? And so one of the things I've done as CTO was to reduce and kill so many meetings so that engineers can actually engineer and not do something else because people want something, right?
Yeah. Um, so I think it seems to me that this is a very exciting time for Scaleway. I mean, you mentioned that you have a really exceptional growth rate, it sounds like. And, the AI boom is obviously very interesting for your business. It's just a very interesting time for Scaleway. So I wanted to kind of finish by just asking you what you personally are most excited about in the future of Scaleway.
Um, I think that people start realizing that we actually can be an alternative to American cloud providers. And it's not just like words, it's actually, it does work today, right? And this is like something that is really cool and makes so many people interested in what we're doing. And really, this is like really, really nice because Scaleway is going to arrive at a point where you're going to continue seeing this growth with more people moving some of their workloads to Scaleway. And so you will, and because all the base products are done now, you can optimize and not just build features. And this is also one of the cool part of being working on a cloud provider.
You're approaching maybe a tipping point.
Yes, I think
Uh,
so.
so, last question, is there anything else you wish that we had the chance to discuss?
Yeah, I'm doing other things on Scaleway in Rust, right? Because and we've not talked about that, but so I've been working on the VLC media player project for 20 years, right? And this is a place where VLC is mostly in C and assembly. And since a few years, we have a way to create VLC. VLC is done with a ton of modules, right? Around 500 modules. And now some of them are written directly in Rust because we have everything, all the internal API of VLC are exposed as Rust crates that you can use. Um, it's quite interesting. And this, in that place, we see a bit of the limits of Rust, in my opinion. Rust is not really good to integrate inside C programming. It works well, but there is so many things you need to do with bindgen and cargo. It's not a pleasant experience, but it works. And when it works, it's perfect. Mostly because on VLC, we pass a lot of files and format and networks, right? And this is one of the place where having some security and mostly the borrow checker is useful. So I've been doing that also with Rust for last 6-7 years. And I'm also launching a new project called Kyber, which is full Rust. It's a SDK to control machines, desktop, remote computers like TeamViewer or Citrix or Parsec, but also doing remote 3D, remote AI rendering that you're going to have visual and you're going to stream directly to a smaller device like your phone. And also controlling of robots or drones in distance, right? It's really about like extremely low latency control of machines. And there, everything we do is in Rust, right? From day one was full Rust. And it's a pleasure because, for example, we have a web version, right? Because some part of Kyber are based on VLC, so we support so many platforms, but there is a big platform which is a web. And there, we don't write JavaScript. We do only everything in Rust and compile everything with the Rust compiler for WebAssembly. So it's not like the things that I've done in the past where I was using mscript10, which is also not very pleasant because when we ported VLC to WASM, this is what we did. Here it's like really cool. And so we can attack and use the web API directly from Rust. And it has been a great experience, actually.
That's cool. I have heard of several companies that use Rust. Maybe I think robotics companies are the ones that I've heard. They use Rust for everything in their robotics stack. And then they also use it on the web because it makes it easy for their same software engineers to, you know, to build that stuff as well.
Yeah, for us, everything like the core of Kyber is a custom networking protocol for real-time streaming of data, and it's the same code that runs on Windows, Linux, Mac, Android, Apple TV, iOS, Quest, Apple Vision, and the web, and it's because we are using Rust.
Yeah, that's a big deal.
So yeah, so that's one of the other things, which is outside of Scaleway, but like big Rust user on those either VLC and Kyber projects.
Yeah, I think this was before we started recording as well, but you are very entrepreneurial and have so many projects going on. So it's very cool.
Yeah,
Um,
on VLC it's mostly open source project, right, with a non-profit. But yeah, it's really cool to be doing many things, right? Because when you're blocked in one project, right? I need time to process it like on the background on my head, right? So working on something else often unlocks the other parts, right? So it's a weird way of working, but it works fine for me.
yeah. With Kyber, if it's okay, I wanted to ask a follow-up on that.
Sure.
Uh, what are you doing differently to achieve that super low latency that you mentioned?
Um, we use Rust, but the way the protocol, like in video for a long time, you care only about quality and high fidelity and 4K and HDR and so on, right? But when you're going to control, and video is a core when you're going to control um, uh, uh, a machine, right? Because you want to have visual feedback, right? To know what is happening, right? Because you are very far from your machine, right? So video is a key part. But everything we've been doing on video was about high fidelity. While here, well, we don't really care about quality. Quality is nice, right? And we need to have the best quality. But latency is more important, right? Because you're controlling a machine, right? And it might be a car or a drone, right? And so it's in the real world, right? Or if it's a software, right? Like you want your clicks to go as fast as possible, right? And have the feedback quickly, right? And if you've ever used VNCs when you click and you wait for the mouse and the menu. It's horrible, right? So everything is focused on having the lowest latency ever, even if you degrade the quality, right? And it's an approach that is quite different from the others. And also because we think that on the client side with some machine learning, you can recreate some of the quality if you have enough of the visual tools, right? So we're going to only focus on lowest latency as much as possible. And then we'll see how we can do bandwidth adaptation, increase the quality and so on, right? But we start from the other part, which is how can we go lowest. And also we base everything on Quick, and Quick is very well integrated in the Rust ecosystem. So that was one of the big reasons for me using Rust. The second thing is instead there is many software for remote control, but they are very on like one niche, right? You have like TeamViewer, you have some for drones, and here the idea was to do something that works everywhere. And we achieved that by doing a lot of modules, but also using everything that we know about FFmpeg and VLC, and everything. The difference between controlling a drone and a computer in our stack is very small, like hundreds of lines of code, because everything is a module and modules of modules, and we reuse a lot of the things that we've done on VLC. And by reusing that, right, our server runs on Mac, Windows, Linux, Android, iOS. Our client runs on Windows, Linux, Mac, Android, iOS, Apple TV, Android TVs, Chromebooks, iPads, Apple Vision Quest, and so on, right? And because we use Rust, we also have the version in WebAssembly, right? And before Scaleway, I was CTO of a cloud gaming company, right? And this took like supporting all the OSs, right? Took months of development. Here we reuse cross-platform solution. We use Rust, and we like the fact that the light object abstraction with traits of Rust is very important, right? Because in all of the OSs, we need to be able to remote a mouse, keyboard, gamepads, USB over IP, printers over IP, copy paste, file transfer. And so like we have an abstraction with some traits that we know to serialize on the network. And so then you just focus on really like the integration. And when you move to another OS, you just do the OS integration and it scales correctly and it helps a lot on the development time. So I think those are the things. And finally, of course, we do a ton of things on security, but that's maybe like a bit like it needs its own podcast to talk about that. So we're doing things quite differently, but we care about speed nonstop, and Rust is a good fit for that.
Yeah. Well, you mentioned that we'd need another podcast to talk about the security stuff. I think we could talk forever. But I think this is a good place to stop. So thank you so much. This was a fun conversation.
Thanks, Andrew.